Karibuni tena. In the last video, we really focused on IP addresses, subnetting, really understanding what the subnet is and the subnet mask is. And this week, I want us to go back to the OSI model and look at two layers. We want to look at the network layer and the data link layer. In these two layers, we're going to be looking at two protocols, ICMP, and we'll be looking at address resolution protocol. I had mentioned that the switch uses address resolution protocol to be able to know the different MAC addresses that it needs so that it can be able to forward traffic between one computer to the next. Our computers also need to know the MAC addresses of the computers on the same local area network so that they can be able to communicate with them. We want to really look into that and really understand how does this all work. So let's get into it. I'm going to start with the Internet Control Message Protocol. The Internet Control Message Protocol, it's a helper protocol used by computers and routers to send error messages and test connections. ICMP is like a network messenger that tells you if something went wrong or confirms if another device is reachable. ICMP basically is used to test if a computer is online. You know, when you connect computers to a network, you want to see if that computer is online, if it's communicating to the rest of the other computers online. So we use ICMP to be able to see if this computer is online, to see if there is an issue in getting to this computer. So most network admins use ICMP, or someone in IT, we all use ICMP to test and see if there's something wrong on the network. You've seen me do this before when I do something like ping 10.10.30.1. And you've seen replies like this. We've done this before. So that is the Internet Control Message Protocol at work right here. Common use is ping. When you use ping command on your computer, how does this work? So your computer usually sends an ICMP echo request. It sends an echo request to the other device, like let's say Google or let's say another computer on your network. That device replies with ICMP echo reply. And that's it. Literally, that's it with ICMP. So when you do, let's say this computer down here, when you do ping 192.168.1.20 from this computer, it would send an echo request and this one will do an echo reply. And this happens 4 times. That's why you usually see 4 replies like this. So you only see the reply actually from that computer. So we'll send 4 requests and it will do 4 replies. Let me show you an example using Packet Tracer because this is easier. I have a network here. The network address is 192.168.56.0, the network address that we were looking at, and it's a /24. That means the subnet mask is 255.255.255.0, meaning we can have 256 possible addresses. If you take away the network address and the broadcast address, we remain with 254 address. So we can connect around 254 computers on this network. If we add a router, we'll give our router an IP address. That means we'll remain with 253 addresses to have our computers connect to this network. So I have this network over here, and we want to see how the Internet Control Message Protocol works. What we do is we'll go down here at the bottom right and then click simulation so that we can see how packets are sent. We'll click simulation and this is what will show up. And then I just want us to clear first, show none, and then you'll see none like this. Once you click this show all /none, and then you see none over here, event filters, value event, visible events, none. Just then click edit. I want you to click ICMP over here, which is Internet Control Message Protocol. That's the protocol we're looking at. It's a network protocol, layer 3. So once you've done that, close that, and then click on your computer. We want to do a ping. So I'm pinging from this computer. The IP address, I gave this computer an IP address, 192.168.56.15. This is the subnet mask. And this other computer has an IP address, 192.168.56.25. That's the subnet mask. We talked about the subnet mask. So that's the That's the IP address of that. And then once we come back and do our ping, so ping 192.168.56.25. We already did our ping down there. When you click enter, you see an echo request envelope is formed. And if you look at layer 3, once you click on it, once you click on that envelope, you can look at this is the OSI model, the one that we've been talking about, and this is layer 3. And we are dealing with IP addresses, Internet Protocol address. We already talked about IP addresses when we were in the last video. So it's coming from, this is the source IP address 192.168.56.15, and it's going to 192.168.56.25. That's where it's going. This is an ICMP echo request. When we click this arrow on the bottom right to go forward, the packet should literally move to the switch. And when you look at the switch I told you only looks at the MAC address. So switch is layer 2 dealing with the MAC address. It looks at the MAC address, the source MAC address, and the destination MAC address. So source MAC address is PC0, destination MAC address is PC3 down here. Close that. And then connects to that. When it gets there, we can see this computer decides to reply. So when you see inbound and outbound, inbound, this is how it came in, yeah? Layer 3 from source IP address that, destination IP address that, layer 2, MAC address this, destination MAC address that. This is the source, this is the destination. Now it's leaving that computer. Source IP address has changed to 25, 192.168.56.25. Destination IP 192.168.56.15. It's going back here, remember? And then when we click, goes back to the switch. Switch only looks at the MAC address, so it's coming from that MAC address going to that MAC address. Then there's a reply. That's the first reply. When you open your command prompt, you should see the first reply down there. See, the rest of the other replies are not yet there. So I'm just going to fast forward this. You see the envelope changed from green to purple, so it's sending another echo request. Goes to the switch as normal, goes to the other computer replies, and then goes back to that computer. And when we open our command prompt, we see another reply down there. Then this one generates another echo request, sending it to the switch, to the computer. This computer replies, and we get another reply. And then the fourth one is going to come. So that generates another one. We send it over the network, goes back to the computer. When we open, we get this. Okay? Now we've looked at the Internet Control Message Protocol. And we noticed the way that just worked. We were able to send packets from the first computer to the other one, and it replied all the way. And we could see the four echo replies. Now we really want to see, the way that computer, how did it even know the other computer is on that other side? How did it even know the MAC address? Yeah, how did that first computer know the MAC address of the next computer that it was sending information to? Because what we knew, when you notice, when we did ping 192.168.56.25, we knew the IP address. So imagine these computers, it's just their first time on a network. We've connected all of them to a switch. Nothing has communicated yet. Nothing has forwarded traffic yet. We all know that the switch, in some of the videos that I had posted earlier, I spoke about the switch having a MAC address table. And from this MAC address table, this is how it's able to forward to, it's able to know which PC is connected to what port and what's the MAC address of that PC. So now, when I get a switch, the first time I get a switch connected to a network, connect all the computers to that switch. Our computers, the switch doesn't have a MAC address table. The switch, then the MAC address table is empty. That's what I mean. The MAC address table is empty. So the switch doesn't know what computer is connected where in the very beginning. And also, I just told you that our computers also need to know the MAC address of the computer they are sending to. And that's where address resolution protocol comes in. Because when we first connect our computers, they also don't know the MAC address of the other computer that they're trying to send information to. And address resolution protocol comes in and helps us solve all this. So we want to look at address resolution protocol at its best and doing its work. We just looked at ICMP. I'm going to clear that and I'm going to return it back to real time. Actually, simulation mode, I'm going to click show none. My event list is now empty. Go back to real time. Since this network has already communicated, the switch we've seen, the switch already knows the MAC address for this computer and this computer. What I'm going to do is I'm going to click this. When I click that, it says configuration not in the startup configuration will be lost. Reset the network. So I'm resetting the network as if this is the first time I've connected all these computers together, okay? So everything is new. The lines are just turning green. Everything is coming up to life. I want us to see that this switch has no MAC address table. So to get to the switch MAC address table so that we can see the MAC address table of the switch, we just double click the switch. It should open somewhere here and then you just click CLI. When you click CLI, come here, click enter, you will see this. And when you see switch like that, just type enable. I had already typed enable. So just type enable like that and then press enter. When you press enter and then type show MAC address and then hyphen table. When we do this, see our MAC address table is empty. Our MAC address table is empty. So nothing has communicated anywhere. The switch doesn't even know who is connected where, okay, on which port of the switch. And the way we usually even check our computers usually have an address resolution protocol table, ARP table. Think of it as a phone book for the MAC address, but our phone book only shows this IP address has this MAC address. So all of them are numbers. Let me show you what I mean. When you type ARP-A like that, we see the internet address, something like 10.10.10.30.1. This is the IP address, and it's showing us the physical address, which is our MAC address. And that's how our computers know. So our computers have something called an address resolution protocol cache. So this is the address resolution protocol cache, where it shows what IP address resolves to what MAC address. Okay? So if I come to this newly connected computer to my network and I type ARP-A, see, it tells me no ARP entries found because this computer hasn't communicated to anyone on the network. So these computers haven't communicated and the ARP cache has not been populated yet. So how does address resolution protocol work? So this computer is connected to fast Ethernet 02. That is the second port on the switch. This other computer, PC0, is connected to the first port of the switch. This other computer is connected to the fourth port of the switch, and this one is connected to the third port of the switch. Okay. Now, when I come and before I do that, let me edit my filters. I'm going to edit my filters and then click address resolution protocol. Everything else is not checked. I'm only selecting ARP. Once I select that, I come to this computer. I need to find what is my IP address. So IP config. This is my IP address. Cool. That's my IP address. If I want to see my MAC address, I could do IP config/all. And this is where I see everything. I can even see My MAC address is right here, physical address. It ends in C2, okay? Now, what do I want to do? I want to ping the other computer. Let's ping this one. Can't remember the IP address of that computer. So let me just come to it. The IP address, you can see it right there. 192.168.56.20. So that's what I want to ping. So come down here and do ping 192.168.56.20. Now when I do this, I click enter. We have our first address resolution protocol. Right now we're not looking at the ICMP. So we are only looking at one protocol, which is in layer 2, address resolution protocol. This is the protocol that the switch and computers use to be able to know the MAC addresses of the other computers or resolve the IP address to the MAC address, okay? So you can see it's coming from my MAC address, this one, C2, and it's going to a MAC address called FFFFFFFFF. So what is that? I need to show you a picture first before I get in deep into all this and show you exactly how ARP works so that you can be able to understand. So what usually happens is this. Let's start from the very beginning. When you look at this image that I'm showing right now, I have PC1 right here. PC1 is trying to send information to PC2 right here. That's the MAC address of PC1. That's the IP address. Our ARP table is empty. This is the first time our network is communicating. So this PC1 will generate a frame, and that frame will have destination address FFFFFFFFFFFF. This is called the broadcast MAC address. So we are broadcasting it to everyone. Remember what a broadcast message is. We are broadcasting it to everyone. And the way we broadcast it to everyone is when we use a broadcast MAC address, FFFFFFF. And then we'll have a source MAC address from the MAC address of our computer. And the message contained in it will say who has the IP address 192.168.1.20, which is up here. 192.168.1.20. And we know this IP address because we did ping. You know, when we did ping over, like in this scenario, we're doing ping 192.168.1.20, which is PC2. So it would say who has 192.168.1.20. Tell our computer PC1 192.168.1.10. And the packet will go hit the switch. What the switch will do, because the switch has a MAC address table, it will look at, this packet is coming from port 1. So what is the MAC address connected to port 1? What is the MAC address of that computer connected to port 1? The MAC address is A24B19 3D779C. So it would record that in its MAC address table. Say this MAC is at port 1. And then what the switch will do, because the MAC address that we are sending this to, the destination MAC address, is a broadcast MAC address, it will send that message to everyone. It will forward it to everyone, okay? So, and the message is still there. Who has 192.168.1.20? Could you tell? 192.168.1.10. Could you tell PC1 in short? And you see all of them receive the same message. Now, what happens now? This computer, since it has received that message, it looks at the IP configuration is over here. It's 192.168.1.25. So that's not me. That's not PC4. Whatever it decides to do is it ignores that frame. This is our router down here. This is a router. It also receives. So when a router is on a network, it also receives the same thing, because a router is still a computer and it also has its own MAC address. So that also receives, and it says, that's not me. It ignores. PC3 over here with an IP address of 192.168.1.30 receive the same packet. It ignores that packet because it's not them. And then PC2, when PC2 receives that address, it notices, that's my IP address. So, oh, that's me. Then it does a reply now. It doesn't ignore it. It does a reply. It says, so now it sends from its MAC address B4A 193D779C, sends from that address to our MAC address of PC1. It sends to that, and the message contained in this envelope is I am 192.168.1.20 and my MAC address is this. Okay? And then now it sends. That message goes from that computer to the switch, and then the switch now realizes this is the computer that's sending. The MAC address is this B4 all the way to 9C. That one, it records it. It looks at what port is it coming from, port 2. So it records it in its MAC table that it's coming from port 2, and that's the MAC address. And then forwards that traffic back to computer 1. And computer 1 now populates its ARP table, address resolution protocol table, and says 192.168.1.20, the MAC address is that. So now the next time when this computer wants to send something, it just sends to this MAC address instead of forwarding it again to a broadcast address. And then that becomes, then that's way more safer. So that's how ARP works, basically. And when we go back to our packet tracer simulation, we see it happening. So this computer, PC1 down here, is sending a message to a broadcast. And that message says, who has the IP address 192.168.56.20? Please tell 192.168.56.10. When you click next, this message goes all the way to the switch. The switch recognizes it's coming from this MAC, going to the broadcast address, and then the switch will decide to populate its MAC address table. So let's click on the switch and then show MAC address table. And you realize the switch is now saying Fast Ethernet 2 has this MAC address, which belongs to our computer down here. Now we forward it. It goes to everyone on the network. And you see that these two have decided to ignore the packet. These two have decided to ignore the packet, but this one is going to reply. And when you look at it, this is the inbound. It came from this MAC address, went to a broadcast address, and now the reply is coming from the MAC address of this computer, PC2, and it's sending it directly to this PC down here, the MAC address of this PC down here. So now as we reply, it comes from that computer, goes there. Now the switch is about to populate its MAC address table again with this computer's MAC. So when we do that, and then we do that command again, show MAC address -table, we see that the switch populates its MAC address table with this address, with this MAC address for PC2. And that PC2 is connected to port 4 of the switch. All right. Then, moving on swiftly, it comes back to this guy who had requested, and now it acknowledges that it received. So now it has the MAC address of PC2. It came from that, and you can see it's coming back to this MAC address with the IP telling us, oh, my MAC address is this. And when we look at the ARP table of this one, ARP-A, then do enter, now we can see that our ARP table says 192.168.56.20, the MAC address is this. So the next time this computer needs to communicate with this other computer, it won't send a broadcast message. All the other computers, they will do the same thing when they're trying to communicate. so that the switch can also populate its MAC address table with all the other computers. The way we can see this on a normal network, because Cisco Packet Tracer is just a simulation, and it helps us slow things down to be able to see how packets, frames, data, bits are sent over the wire. Now, the way we can see it on a real life network, real life example, we use a tool called Wireshark. Wireshark is literally like tapping on the wire and reading everything that's going through the wire. So let me show you what Wireshark is. You need to install it. Just go online on your favorite browser and type Wireshark. You'll see wireshark.org. Download the software, install it, run it. So I'm going to run my Wireshark install since I already have it downloaded. And you can see the different network adapters right here. So we have Wi-Fi, the Wi-Fi network adapter. This is loopback address. We'll talk more about loopback addresses when we dig deeper into IP addresses. When you see these lines, it literally shows you that this is where the traffic is. The rest are disconnected, and you can even confirm that by doing this. Remember, we did this. Get net adapter. You can see my Ethernet network adapters down here. They're all disconnected. I'm using Wi-Fi. That's the same thing that we're seeing here. This one is connected and I'm using Wi-Fi. I mean, the rest are disconnected and I'm using Wi-Fi. So if I want to capture traffic on my Wi-Fi network, I just double click on that. And just like that, you will see everything that's going through the wire. We'll see all those protocols. We see TCP, QUIC, UDP, right there, TLS, all this stuff. We'll even see DNS. What Wireshark does, it's snooping on the wire. It's like listening to everything that's happening on the network. It's literally spying on whatever is happening on the network. I can come up here to the filter and filter whatever I want to see. If I only want to see UDP traffic, I can just type UDP. If I only want to see TCP, I can only just type TCP. I can also do DNS. Let me see if there's any. Yeah, see, there's some DNS. But anyway, what we want to look at is ARP. Since my network has been running all through and the computers know the MAC addresses of the other computers on the network, I'll just stop this because I don't need it. I don't need to do this. I can show you one where I captured one of the traffic that I captured using, the first time when I connected my computers on the network. So this is it. This one, I captured it earlier, the first time I connected my computers on the network. And when I type ARP, you can see ARP happening right there. This computer, this is my computer, Intel. That's my MAC address going further. Let's see it. Address resolution protocol. Source MAC address. So this is my MAC address. And it was requesting, and this is my IP. But anyway, my MAC address, this one, it was requesting for the MAC address of 10.10.30.1, which is my router on the network. And it said, who has this? Tell that. Literally the same thing that we just saw happen on Packet Tracer. And I showed you how ARP works right here. So I hope you found that video informational, informative, and very interesting. If you are someone who really wants to understand how these protocols work and how everything works, just go ahead, download Wireshark, build your own network using Cisco Packet Tracer the way we've done, add your IP addresses. I would advise you to do that lab. Just click, do the simulation. You can look at this video again, go through it, do the simulation with me the way I did. Look at how everything works and how everything happens so that you can be able to understand how ARP happens. Because I'm going to let you in on a secret. ARP is also a vulnerable protocol, and hackers really utilize that protocol to try and, deceive and do malicious things on the network. But it can only happen if this person is connected on your local area network. So that would mean that the hacker is literally on your computer or on a computer that is on your network, and that's how they get to control everything. Or probably maybe they're just inside your network, and that's how they're attacking it. But we'll look more into that. It's called ARP spoofing, ARP spoofing. If you are interested, you can go ahead and see how that works. But anyway, we'll look into it later, and we'll even do a hands-on lab on it. But apart from that, I hope you found this video interesting, and hoping to see you in the next video.